Hello guys. This lesson is going to be a little bit redundant. It's kind of repeating some stuff from the previous lesson. We're just going to focus in a little more on asymptotes and holes. So we already did a lesson on discontinuity where this came up. Asymptotes were part of the last two lessons. Having a hole in the graph was a part of the last lesson. If you can't tell, it's kind of important that you have a good understanding of this. So we're looking at rational functions. So y equals a function over a function. So in general, this is all review stuff. You factor the numerator and the denominator. You really want to do that. It makes things a little better. If factors cancel, that creates holes. The non-canceling zeros in the denominator, those create vertical asymptotes. For horizontal asymptotes, there were these three situations. The degree of the numerator and the denominator are equal. In that case, you make a fraction out of the lead coefficients, and that is a horizontal asymptote. Or the numerator is less than the denominator. In that case, y equals 0, or the x-axis, another way to say it, is the horizontal asymptote. The third scenario is the top is greater than the bottom, and in that case, there is no horizontal asymptote. A special little extra note, if the degree of the numerator is 1 more than the denominator, so that's still situation 3 here, the top is greater than the bottom, there's no horizontal asymptote. But if the numerator is exactly 1 more than the denominator, so let's say, for example, you have like x cubed over x squared or something like that, then there is a slant asymptote, slant, which is also referred to sometimes as an oblique asymptote. That's not really part of the lesson, but it is a fact. It is true. It's part of mathematics, so I thought I would throw that in here. Okay. So let's look at what we're going to do. No graphing. So there's no graph paper here. I just want you to be able to identify the holes, vertical asymptotes, and horizontal asymptotes of each equation. So call this extra practice if you want. All right. One very helpful thing is to factor both. The top cannot be factored. The bottom you can factor out a 2. All right. Let's look at let's see. Holes, vertical asymptote. Okay, so set the bottom equal to 0. 2x minus 2 equals 0. Of course, that 2 you just divide. It doesn't really do anything. Add 2 to both sides. So this is a discontinuity. The question is it a vertical asymptote or a hole? Well, this has nothing to cancel with. Those do not cancel because one's plus and one's minus. Remember, you only get holes from canceling. So that means that the vertical asymptote is x equals 2. As far as a hole in the graph, there is none. And for a horizontal asymptote, well, this we go back to the original. What is the degree of the top and the degree of the bottom? In this case, they are both 1. They are the same. So the horizontal asymptote is y equals lead coefficient over lead coefficient, 1/2. And that's it. That should be all of the answers for number 2. And there it is. Vertical asymptote, no hole, horizontal asymptote. So that's it. That's what we're doing here. That's what we're doing on every problem. So here's what I'm going to do to make my life a little easier. Oh, no, almost. I'm going to duplicate this, drag it down here. Then you know what? Let's go ahead and duplicate it again. Drag it down here. Duplicate again. Yeah, you see what I'm doing. Yeah, there we go. All right, number 4. So factor the numerator and the denominator. The numerator is a trinomial, so I can go x, I think, plus 3 minus 1. Yep. The denominator, I just factor out a 3, and I come up with that. Set the denominator equal to 0. Okay, so last time I did something like this on the last problem, and the first thing I did is divide that 3, which basically got rid of it. So as it turns out, all you have to do is set the algebraic factors equal to 0. If you got a constant factor, you can basically disregard it. So x equals -4. That is a discontinuity. What type of discontinuity? Is it a vertical asymptote or a hole? Well, This factor has nothing to cancel with, which means it is a vertical asymptote. It'd be nice if I could write correctly. Come on. X equals -4 is a vertical asymptote. Like the last problem, there is no hole in this graph. The horizontal asymptote, the top is greater than the bottom, so that means there is none. Now, just to review what I said a few minutes ago, the top is exactly 1 more than the bottom. 2 is 1 more than 1. So this would have a slant asymptote. Not part of this assignment, but you could have an assignment conceivably where there is slant asymptote, and then you would have to, answer that. But we're not doing that. That should be it. Number 4, let's see. Yep. Good. All right, number 6. Oh, this is going to be fun to factor because each one is going to take a couple of steps. So in the numerator, I can factor out an x, and that gives me x squared plus 7x plus 12. But that can factor even further into x plus 3 plus 4. The denominator, I can factor out a -4 from every term. That gives me x squared plus x minus 2. And then if I factor that, x plus 2 minus 1. Well, let's see, nothing is going to cancel anywhere, so there's no holes in this graph. Well, this would be boring if I made a whole worksheet with no holes in the graph. Vertical asymptote, so you set the algebraic factors equal to 0, and you're going to get -2 here, and add one +1 there. So 2 vertical asymptotes. Horizontal asymptote, again, the top is greater than the bottom, so there is none. So that should be the answer to number 6. Let's see. Yep. Okay, let's look at number 8. Factor this. X minus 3 minus 1. Excuse me. The bottom I can factor out a 3. And then I can continue to factor that. So let me just bring this down. X times x, 4 times 1 is 5. Minus 4 minus 1. Oh, okay. Now, do you see that we do have that? So if I set the algebraic terms equal to 0 in the denominator, this gives me the discontinuities. X equals 4, x equals 1. But the x equals 1 comes from a factor that'll cancel. So x equals 1 is a whole, whereas x equals 4 is a vertical asymptote. For horizontal asymptote, the degree of the top equals the degree of the bottom, so it's y equals, and then what? You make a fraction out of the lead coefficients, 1 and 3. 1 over 3. That should be the answers to number 8. 4, 1, and 1/3. Good. Number 10. Factor the numerator and denominator. There's nothing to factor. For discontinuities, set the denominator equal to 0. You get x equals 4. There is no x minus 4 term on the top to cancel with, which means that this is a vertical asymptote. There is no hole, so none. Horizontal asymptote, well, the degree of the top here is 0. If there is no x, that would be like 0 x's. So the degree of the top is 0, the degree of the bottom is 1. This is a case where we have the numerator is less than the denominator. And in case you forgot, that is this situation right here, situation 2. So y equals 0. Where am I? Good grief. Y equals 0 is the horizontal asymptote. So number 10, and there we go. Number 12, and we're done. So hopefully this is easy for you, or it's coming along. Kind of the 3rd day in a row on the topic, and we're just expanding it ever so slightly. We're not changing a whole lot here. So The bottom I can factor out in x. I get x squared minus 4. Wow, that's an ugly 2. And I can continue to factor this. So the top is going to be x. Let's see, 4 times 2 is 8. 4 plus 2 is 6. The bottom, what I have here is a difference of squares. So that's x minus 2 plus 2. Now, if I set the algebraic factors in the bottom equal to 0, I have 1, 2, 3 factors. X equals 0, x minus 2 equals 0, x plus 2 equals 0. Solve them. Well, that's already solved. This one I have to add 2. This one I have to minus 2. So those are discontinuities. 3 discontinuities here. If you look back one step, if I were trying to reduce this fraction, those 2 terms would cancel, which makes this a whole. And those 2 terms would cancel, which makes this a whole. So x equals 2 is a vertical asymptote. X equals 0 and x equals negative 2 are both holes in the graph. For horizontal asymptote, the degree of the top is 3, degree of the bottom is 3, so this is where I make a fraction out of the lead coefficients, which are both 1. 1 over 1 gives me y equals 1. So my answer had better look like that. Right, 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 and right. All good. So if you are on top of things and you are pretty good at factoring, this assignment should go fairly quick and easy, only 6 problems. If you struggle with factoring, it might take you a little more time. If you can't remember all the rules off the top of your head like I'm able to, you have to scroll back up and check out these notes every so often. That could add a little time to it as well. But I will go ahead and stop here. You definitely contact me if you have questions and I can work through that with you. Otherwise,